Alright, so next one we're going to deal with the auxiliary projection to cylinders. Alright, let's see this principle. So we're going to deal with it first as a true size and shape, yeah, surface A. Then you have two surfaces A and B and your line of intersection right there. So we're also dealing with the angle in between them, yeah. The problems and this kind of problem, so you have to solve two things, yeah, going on here. When you carefully look at what we are given here, you are dealing with a cylinder, yeah. So you look at the shape, yeah. It's not the rectangular type of shape that we are familiar with in previous examples. So here we're dealing with a cylinder. The cylinder, you know, it's kind of like you have a circle, yeah, and then go with a height up. Okay, we will use the same procedures that we've been doing in many of our problems. Yes, we have been through many different types of problem solving already between two sides, true size, the shape, and the true angle. Yeah, so let's take a look at this. So the very first thing we do, we have two views as always, yeah, and your top, of course, and then your front, and we have to verify all of our points, and then their corresponding views by constructing the full line in between them. So we're going to draw that first. Yeah, here, there's my full line, first full line. Yeah, you can see it very clearly here. Yeah. All right. Then we're gonna label all the points. Yeah. So we have 1, 2, 3, 4. The surface B surface is here on top, so you can see only from the top view. You can see this. Yeah. Surface A here, surface B is right there. Yeah. 3, 1, and 2. So you have 3, 1, and 2 right there. I hope you can be able to see the views, your top reference, and then your right side, yeah, very quickly now, I hope. Alright, and then we're going to come with the center planes. And then we're going to divide our circular view into a minimum of 16 points, yeah? So we do 16 points, and then we're going to divide that, and then give us 16 divisions in your circle, like pizza, yeah, cutting. Or a pie cutting, yes, but make it like a 16 slices in there, or 16 divisions right there, yeah. Then you're gonna project them into the front view and label all points, right, in both views. Oh my gosh, getting more and more complicated. This is just a PowerPoint slide, so you can't draw really big. Yeah, when you draw in your graph paper, make sure that you draw right there. Yeah, so that way you can get all of this, the 16 divisions. Projectors onto your front view, from the top view to the front view. Yeah, bang, 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 just go straight down. So we have 1, yes, and then 2, and then 3, okay, and then 4, 5, 6, 7, 8, 9. Your 10 to 11 is there, 12, 13, 14, and then you have your 15 and 16 right there. Okay, so when you take carefully look at this, how we divide it, yeah, so coming out from there, yeah, you have 1 and then 3 and then 2 and 4 right there, corresponding to your front view. Okay, and then we start giving, okay, 4, 5, 6, 7, 8, 9, see that? And then 10, 11, 12, 13, 14, okay, and then 15, and then jump to 16. Okay, so if you can't see it, I can try to you use some sort of a highlighter, yeah, so you can highlight it like this. Okay, it might be a little bit difficult for you to do it. So you have 1, 3, 2, and 4. Okay, make sure you highlight 1, 3, 2, and 4. Okay, right there, like that. And you, of course, 1 is here. Yeah. So after 4 is 5. So we usually go like this. Okay, count. So 5, 6, 7, 8, 9, and then 10, 11, 12, 13, 14, 15, and 16. Alright, so that's how we divide. Okay. Alright. I'm gonna go ahead and erase, all of this that we need to erase. I'm gonna go ahead and erase this one as well. Wait, what am I doing? I'm supposed to erase this. Okay, go back. Oh, I got it. My eraser is no good. Oh, it's working now. Okay. Okay, so once we finish with projections, our full line right there, we're going to deal with this intersection line. All right, so this is your line or intersection 1, 2. Yeah, see this dark line right there. And we have to also determine our true length. Yeah, so the true length is the one, again, got to be projected from the line that is perpendicular to your first full line. So look carefully. Is anything that's perpendicular to this? Yes, right there, base. See, right here, 1, 2, parallel. Sorry, parallel to your full line. Okay. So therefore, we don't have to get our true length. We don't have to manipulate to get the true length by adding another full line. Yeah, here you have the full line, and we have a very visible parallel line, which is line 1, 2, parallel to the full line or reference plane. So therefore, the projection of your front view and your top view, 1, 2, line 1, 2, okay, which is the intersection of the surface A and B, is the true length line. Okay. All right, so true length line, draw the extension, add another line of distance of your full line, your line of your reference plane. Okay, and of course you draw all of your projectors, yeah, perpendicular to that full line. And we're going to add our directions, all right, direction for your dimensioning, your distances, and then I'll draw all the points, yeah, equal distance from the reference plane, first reference plane, and then all the points got to be equal distance, all right, from the second reference plane as well, and then connect all of it. Okay, so now you get, all right, the primary auxiliary view. And then from there, we're going to get another full line, okay, coming into this direction, and we will go that direction. So your measurement is going to come from this full line, all right, down. And we'll be drawing all of the projectors, all right, straight down, just perpendicular to that full line, your third full line, okay? So get all the points and then connect them. Okay, so this is your right side view. Okay, right side view of this guy. Yeah, so it's your front view, and we're looking at it from the right side. Okay, your line 1, 2. Okay, so right here, so we have 1, 2. Yeah, I'm gonna highlight it so you can see it. This is, see, on a straight line, so therefore you get only a point. And then we're gonna come down straight line. Okay, so you have 1 and 2 right there. Okay, so that's a line or intersection. Okay, where's my eraser? So make sure you draw highlight it, yeah, that way you can be able to trace your line or intersection right there. So that's between surface A and B. When we draw our secondary auxiliary view right there, you can see the surface B, okay, is a foreshort-tangent. Yeah, surface B is foreshort-tangent in our right side view. Okay. It is foreshort-tangent your surface B is because your surface A, all right, is completely projected perpendicular, to the edge view. Surface A became the edge view here, in your primary auxiliary. So here your secondary auxiliary is your right side view. We still have, okay, it will be shown in the true size and true shape right here, but it is surface B is foreshort-tangent, okay, because it's coming out from the edge view. Okay, and then we're going to use the same projections, and then we will complete, okay, this right side view, because you have this portion of it. Yeah, we get this, but we got to do this. So now you have this, and then we will be drawing this, okay, straight down, of course, all of our projectors, and then complete the other part of your cylinder on the right side view. Okay, draw it, right, visibly by using a thicker construction pencil, and then you get it. Okay, and that's your right side view. Now you will erase all of this mass line right there. Yeah. So you get here, here, and here. From the secondary, yeah, from this primary auxiliary view, you can be able to get your true angle, yeah, because you have surface P, surface A, and edge view, which are lines, yeah. This is a point of intersection of the edge view lines, yeah, coming out from these two surfaces, the line of intersection, the point of intersection between the edge views of your surface A and B is your true angle, yeah, pretty big angle, over 90. And then of course here is your right side view, yeah, and that is your true size and shape, because we're keeping the true size and shape by measuring our transfer method, yeah, coming out from there. Okay, so now we have solved the true size and shape, and then we have solved the true angle, yeah, from two given views, your front and your top, with two surfaces and a line intersection, okay, of a cylinder, yeah.